Welcome back to Fun with Neural Networks. Let's play. As promised in the last video, we're going to be looking at the sigmoid function, which is defined as 1 over 1 plus e to the negative x. And we're going to look at how differentiating that will get you to the sigmoid function itself multiplied by 1 minus the sigmoid function itself. Or if you like to expand it out, this whole big thing. All right. Looking at the graph, we can see that the function itself, which is in blue, kind of has an S structure to it, right? Kind of looks like an S. And then the derivative, which is in green, it has this little bump over here in the middle. And what that just shows is that is the region of inputs where the function is most sensitive to change, right? That's where changes affect the function overall. And so without any further ado, let's get to it. I'm gonna pick my black pen over here, and then we're gonna start. We're gonna use the quotient rule from calculus that states when you have a function y, which is u over v, which is a fraction, the derivative d dy would be v du minus u dv over v squared. I'm sorry if you have a hard time, telling the difference between my u's and my v's. I do have a hard time too. But moving on, we have that looking at this, our u would be 1, right? From this function here, u would be 1, and our v would be 1 plus e to the negative x. And naturally, du would be 0. Derivative of a constant is 0, and dv would be negative e to the negative x. All right, looking good. Now, plugging these values into our formula, we have that ddx, the sigmoid of x, is v du. So our v is 1 plus e to the negative x multiplied by 0, which is du, minus, and we're going to put a little bracket over here, u dv. So u is 1 and dv is negative e to the negative x. All right, all divided by, I'm sorry about that line, all divided by v squared. It's no longer v squared. In this case, it is in fact 1 plus e to the negative x squared. All right, so of course 0 is gonna cancel out this whole thing. 0 doesn't like to have any friends at all, and then these little two negatives are gonna cancel each other, leaving a positive e to the negative x over 1 plus e to the negative x all squared. And so really, this is why I tell you kids not to fight your friends. Really, there's nothing positive that comes out of that. All right, enough. So we're gonna use a couple of tricks. Well, I don't like to call them tricks. They're just really handful rules to help us get to what we want. The first rule is when we have a over b squared, something like this, we can really work it out to be a over b times 1 over b. It's the same thing. And so we're going to do the same thing over here. We're going to say that this is the same thing as e to the negative x over 1 plus e to the negative x multiplied by 1 over 1 plus e to the negative x. And then again, we're going to apply another handy rule, which is that a is really the same thing as a plus 1 minus 1. Do you get it? Because these cancel out. Plus 1 minus 1, they cancel out. And so we could really just write it down like that. And so we're going to apply that change to this guy, and we're going to have e to the negative x plus 1 minus 1 over 1 plus e to the negative x, all multiplied by 1 over 1 plus e to the negative x. And so the last rule we're going to apply is that when we have a plus b over c, can really be worked out to a over c plus b over c. It's the same thing. And so we're going to apply that to this guy. Switching back to my black pen, e to the negative x plus 1 over 1 plus e to the negative x is now separate from negative 1 over 1 plus e to the negative x, all multiplied by 1 over 1 plus e to the negative x. And this multiplication really is applying to the whole of this, all of this. Okay, now from here we can see that this is the same thing as this, and so they could cancel out when you have 1 minus 1 over 1 plus e to the negative x enclosed, multiplied by 1 over 1 plus e to the negative x. All right, I think we are done. Now, if we compare this to what we have over here, let's try to bring it all the way down. Bring it all the way down. Bring it all the way down. And we could really compare these two things. I could rewrite this so that it looks something like this. So bring this guy to this side. We have 1 over 1 plus e to the negative x. 1 minus 1 over 1 plus e to the negative x. And so these two things are the same. And whoa, if you look at it, this 1 over 1 plus e to the negative x really is our sigmoid. And so we could replace it with sigmoid x 1 minus sigmoid x. Okay, so that's it. That is everything. I promise you're going to see the reason why this is actually important in our last video, which is going to cover backpropagation.